Welcome to G Fun Facts Online. For most of human history, space was an impossibly expensive destination. Every rocket launch was like building a Boeing 747, flying it once and then ditching it in the ocean. This throwaway model made space access incredibly rare and costly. But one company, SpaceX, decided to challenge this paradigm with an audacious goal: to build rockets that could be reused, just like airplanes. This is the story of how they turned that science fiction dream into a reality, launching a new era of space exploration. Before SpaceX, the space industry was defined by its expendable rockets. These marvels of engineering, costing hundreds of millions of dollars, were designed for a single, fiery trip. The powerful first stages, which do the heavy lifting to escape Earth's gravity, would separate and fall back to the planet, either burning up in the atmosphere or crashing into the sea. The vast majority of the rocket's cost was lost every single time. NASA's Space Shuttle program was an early, ambitious attempt at reusability. The orbiter itself was reusable, as were its solid rocket boosters. However, the immense cost and time required to refurbish the shuttle after each flight, coupled with the tragic loss of two orbiters, proved that a truly practical and affordable system was still out of reach. The dream of routine, airplane-like access to space remained just that, a dream. SpaceX's journey began not with a giant leap, but with small, iterative steps. Their workhorse was the Falcon 9, a two-stage rocket that would eventually become the world's first orbital-class reusable vehicle. The very first version, Falcon 9, version 1.0, which first flew in 2010, was actually expendable. Its job was to prove the basic design worked and to begin flying cargo to the International Space Station for NASA. But even then, SpaceX was already thinking about reusability, attempting to recover the first stage with parachutes. This method didn't work, but the data they gathered was priceless. The next evolution, the Falcon 9 version 1.1, was where the real challenge began: propulsive landing. The concept sounds simple. After separating from the second stage, the rocket booster would relight its engines to slow down and guide itself to a precise, gentle landing. Executing this was fiendishly difficult. It required new technologies like steerable grid fins, those waffle iron-looking things at the top of the booster, to control its orientation as it fell back through the atmosphere, plus strong, deployable landing legs. The first attempts were, to put it mildly, explosive. In January 2015, the first try to land on a floating ocean platform, a drone ship, ended in a hard impact and a massive fireball. Subsequent attempts also met fiery ends. But Elon Musk and SpaceX famously embraced these as learning opportunities, not failures. With each explosion, they gathered crucial data, refining their software and hardware. Then came the breakthrough. On December 21, 2015, after successfully launching 11 satellites, the Falcon 9 first stage, booster number B1019, turned around and headed back to Cape Canaveral. In a moment that sent shockwaves through the entire industry, it descended through the night sky, its engines reigniting in a final landing burn, and touched down perfectly on its landing legs at Landing Zone 1. For the first time ever, an orbital-class rocket booster had landed itself. The era of expendable rockets was officially ending. Landing the rocket was just the first step. The next was to prove it could fly again. That milestone was achieved on March 30, 2017, when a previously flown Falcon 9 booster launched a satellite and then landed successfully for a second time. With the core concept proven, SpaceX shifted focus to perfecting the system. The result was the Falcon 9 Block 5, the final and most advanced version of the rocket, introduced in 2018. The Block 5 was designed from the ground up for rapid and repeated reuse. It featured upgraded Merlin 1D engines for more thrust and efficiency. Its landing legs were made stronger, and the grid fins were switched from aluminum to more heat-resistant titanium. the refurbishment process became a finely tuned operation. After landing, a booster is inspected, any necessary repairs are made, it's cleaned, and then prepared for its next flight. SpaceX has slashed the turnaround time, with some boosters flying again in just a few weeks. The Falcon 9 Block 5 has since become the most flown rocket in the world, with a launch cadence that is simply unmatched. Individual boosters have flown dozens of times, with one particular booster, B-1067, achieving a record 31 launches and landings as of early 2025. Building on this success, SpaceX introduced the Falcon Heavy. Essentially, it's a strengthened Falcon 9 core, with 2 additional Falcon 9 first stages strapped on as side boosters. This makes it one of the most powerful operational rockets in the world, capable of lifting nearly 64 metric tons to orbit. Its maiden flight on February 6, 2018 was a global spectacle. The payload was Elon Musk's personal cherry red Tesla Roadster, with a spacesuit-clad mannequin named Starman in the driver's seat, listening to David Bowie's Space Oddity as it was sent on a path past Mars. But the real show was the landing. In a stunning display of synchronized precision, the 2 side boosters separated, flew back to Cape Canaveral and landed side by side. It was an incredible demonstration of SpaceX's mastery of reusable technology. The Falcon Heavy is now used for launching large satellites and critical missions for NASA, including components for the upcoming Gateway lunar space station. But even the Falcon family is only partially reusable. The second stage, which carries the payload to its final orbit, is still discarded. Elon Musk's ultimate vision has always been a fully and rapidly reusable system, a vehicle that could be refueled and relaunched in hours, not weeks. This is the holy grail of spaceflight, and its name is Starship. Starship is a 2-stage, super heavy-lift vehicle that will be the most powerful rocket ever built. It consists of the Super Heavy booster first stage and the Starship spacecraft second stage. Both are designed to be fully reusable. The plan is for the Super Heavy booster to return to the launch site and be caught by a giant pair of mechanical arms on the launch tower, nicknamed Chopsticks. The Starship spacecraft, meanwhile, will be able to land on Earth, the Moon, or even Mars. The development at SpaceX's Starbase facility in Texas has been incredibly fast-paced, following a philosophy of building, flying, and iterating. Early prototypes conducted short hops to test the engines and basic controls. Later, full-scale prototypes flew to high altitudes, testing a unique belly flop maneuver for re-entry, where the ship falls horizontally to slow down before flipping vertical for landing. At the heart of Starship is the revolutionary Raptor engine. It's a full-flow staged combustion engine, which is a highly efficient and powerful design, and it burns liquid methane and liquid oxygen. This propellant choice is key because methane can be produced on Mars using local resources, which is essential for Musk's long-term goal of a self-sustaining Martian colony. The Raptor engine has evolved rapidly, with the latest version, Raptor 3, being simpler, cheaper, and significantly more powerful than its predecessors. Another key innovation is Starship's construction. Instead of the typical aerospace aluminum alloys, it's built from a custom stainless steel. This seems counterintuitive, but steel is incredibly strong at both the freezing temperatures of its fuel and the scorching heat of re-entry. It's also far cheaper and easier to manufacture than advanced composites. The orbital flight tests of the full Starship stack have been dramatic. The first, in April 2023, ended in a planned self-destruct after several engine failures. But each subsequent test has shown incredible progress, with the vehicle reaching space, performing key maneuvers like stage separation and opening its payload door, and surviving deeper into the re-entry process. The economic and societal impact of this revolution is already massive. The ability to reuse rockets has dramatically lowered the cost of getting to space, allowing SpaceX to dominate the launch market. This has fueled a boom in the satellite industry, most notably SpaceX's own Starlink constellation. which aims to provide global high-speed internet. Such a project would be economically impossible without cheap, frequent launches. Lower costs are also paving the way for new industries like space tourism, in-space manufacturing, and even asteroid mining. And from an environmental perspective, reusing hardware instead of dropping it in the ocean is a much more sustainable path forward for our expansion into space. SpaceX's success has ignited a new space race. Blue Origin, founded by Jeff Bezos, is developing its own heavy-lift reusable rocket called New Glenn. United Launch Alliance is working on a partially reusable Vulcan rocket. And new players like Rocket Lab, along with the European Space Agency, are all investing heavily in their own reusable technologies. This competition is fantastic news for everyone, as it drives innovation and continues to push down the cost of access to space. The reusable rocket revolution, pioneered by SpaceX, is still in its early days, but it has fundamentally changed our relationship with the cosmos. The Falcon 9 and Falcon Heavy have turned what was once a monumental expense into a routine operation. And Starship, with its promise of full reusability, could be the technology that finally allows humans to establish a permanent presence on the Moon and take our first steps on Mars. The road ahead is challenging, but the past decade has shown that with relentless innovation and a willingness to learn from failure, the impossible can become reality. The reusable rocket is not just about a new type of vehicle, it's about a new future, where the sky is no longer the limit, but just the beginning. Thanks for listening to G Fun Facts Online.